Hello everyone, I will be presenting on climate change revealed through marine flora records. I will be focusing on the key three regions, Australia, Eastern Pacific, and the Western Atlantic in the Cambrian period as evident on map figure 1. Marine flora is used to reconstruct past climate since it provides a record of changes in marine temperature, currents, and other atmospheric variables. Such records are crucial in providing information on how climate has transformed and is still transforming. I will also discuss the role of marine plants in establishing climatological understanding, past climate changes in the particular regions, current climate status, and the future current climate trends. Marine flora as a climate record. Marine flora acts as a paleoeconomic proxy record for climate change. They provide evidence of past ocean temperatures and ecosystem shifts over time. This helps scientists track changes in ocean circulation and global climatic trends. The diverse marine flora are shown in Figure 2a and Figure 2b are equally important for climate records. These records help recreate the climatic conditions of past, provide information on temperature changes, ocean currents, and even the level of atmospheric CO2. Climatic regions examined through marine flora. Climatic map in Figure 3 shows the regions of Australia, Eastern Pacific, Western Atlantic, and Cambrian marine bands from which we will be able to deduce how changes in marine flora was responding to climate changes in the past. All of these regions have been analyzed in great deal to explore historical, current, and possible future climatic conditions. Studying the marine plants in these regions, researchers have been able to collect valuable data concerning how climatic shifts throughout millions of years and how it's shifting at the present. Kelps in Australia, for example, have exposed both paleo and current warming signals. In the Eastern Pacific and Western Atlantic, marine flora, including seaweeds and planktons, provide emergence in isthmus and Panama affected through the temperatures of the sea. There are also Cambrian zones highlighting conditions in the warm global oceans that has been occurred over 500 million years ago. Region 1, Australia marine flora and climatic change. In the region around Australia, as illustrated in Figure 4 below, the kelp forests have been used as climate proxies. These compact underwater communities are very vulnerable to alternation in sea temperature and currents, as Johnson and Nell 2014 say. Seaweeds, especially kelp forests, have revealed a lot about earlier climatic conditions. These kelp forests function as climatic proxies for previous sea temperatures. Studies have established that during a warm phase 150 million years ago, the Australia kelp forest indicated stress from increased temperature of the sea. For instance, studies of the fossil of the ancient kelps indicate that there was a period of global warming some of 150 million years ago. Region 1. Current trends, how similar temperature increases with Australia. At the current moment, kelp forests in Australia are endangered because of the water temperature rise and the increased frequency of storms, which are the result of modern climate change. In the future, the scientists expect the deterioration of kelp forests in Australia waters if the sea temperatures are to rise. Such changes could have significant impacts towards the marine flora. In the Eastern Pacific and Western Atlantic, marine flora such as seaweed and plankton dissipate have Decepted and Figure 6 have assisted in the determination of previous climate changes. They give us information on static shifts in ocean temperatures, and this is well illustrated by the formation of Isthmus and Panama, which join North and South America, is what VEED and Curtin in 2016 said. The Isthmus Panama formation created a division between the Pacific and Atlantic Oceans as shown in Figure 6. Seaweeds and plankton preserved between 3 and 5.5 million years ago, showing that the formation of isthmus changing currents as water temperatures between these two areas. Marine flora and early climate in the Cambrian period. In the Cambrian period, 541 to 485 million years ago, the evolution of early marine plant life, including the seaweeds, was a crucial point on Earth's climatic history. Figure 8 is a world map indicating the Cambrian marine zones. Analysis of the Cambrian marine flora form era in Figure 9 shows that the Earth experienced a warm global climatic shift with high levels of CO2 in the atmosphere and warm oceans. These early marine plants lived in these conditions, and their fossils show as the ocean and atmosphere was like back then. Cambrian period marine algae has been used to investigate the climatic conditions that prevailed from early ages up to date. Marine flora as the key to climate change understanding. Plant life in these three areas has offered the scientific fraternally crucial information about the climatic shifts on the planet over the last million years. The changes in the ocean temperature from 150 million years ago in Australia to the cooling of the eastern Pacific and warming of the western Atlantic after the formation of the Isthmus and the Panama are all reflected in the marine plants. Understanding the marine plant formation of the Cambrian era helps us gain knowledge about the formation of climate on Earth. The transformation that occurred in marine vegetation indicate a growing pressure on marine organisms, and future trends predict further warming that may drastically affect the distribution of species in the seas. Figure 10 shows that the increase in ocean temperatures is having a negative effect on marine environment, which underlines the need for combating climate change.